Chapter 7 is all about exponential functions, and in the first section, 7.1, you're going to learn about graphing exponential growth functions. There are growth functions and decay functions. This first section is about growth functions. The second section, 7.2, you'll be learning about how decay functions work. So first off, let's just talk about what an exponential function looks like. It involves the expression a times b to the power of x. So some number times another number to the power of x. And b is called your base, and it's some positive number other than 1, because if it's 1, it's really not going to get us anywhere, because if you have 1 to any power, whatever x is, it's still going to be 1. So that's why it's something other than 1. And with this function, the function that we're going to graph is going to pass through the point 0, a. So whatever a is, it's going to pass through the point 0, a. So if a is 2, it's going to pass through the point 0, 2. So let's look at a specific example. Here we have f of x equals 2 to the power of x. This is an exponential function. Here our base is whatever numbers to the power of x. So our base here is 2. Our a, well, there's not 1 written here, so our a is just 1, because we can put an imaginary 1 in front of this 2 and it'd be the same thing. So if there's no a written there, we just assume that it's 1. So here our b is 2 and our a is 1, and then we have to the power of x. So here I've already created a table, my x and y, my 2-column table. If I plug in -3 for x, I'm going to get out 0.125. If I plug in -2, I'm going to get 0.25. If I plug in -1 for this x, I'm going to get 0.5. 0, I get 1. 1, I get 2, and so on and so forth. And below, I've graphed these points right here. So this is what an exponential function looks like. It's a curve, basically. And I want to talk about what an asymptote is. An asymptote on a graph is a line that the graph approaches, but it never ever reaches. It never touches that line. This graph has an asymptote. This curve right here gets really close to the x-axis, but it never actually touches the x-axis or crosses it at all. So in the graph above, the line y equals 0 is an asymptote, because the x-axis is the line y equals 0, because this is where y equals 0. We can also look back at our table. If I scroll back up a little bit, if we keep plugging in negative numbers, we're going to see that it gets really close to 0, but it never actually gets to 0. So that's what an asymptote is. So just briefly again, exponential growth function looks like this. Y equals a times b to the power of x, where a is greater than 0 and b is greater than 1. So let's look at graphing exponential functions. This is how you're going to graph these. You're going to plug in the numbers 0 and 1 and graph those 2 points, and you should be able to create your curve from those 2 points. So you are going to plug in 0 and 1, because they're pretty simple. If you plug in 0 into x, you get a half times 3 to the power of 0. I hope you remember that anything to the power of 0 is 1, so we just get a half. And above, if you remember that there was a little note that said that your graph will cross through the point 0, a, and that means that this graph right here should cross through the point 0, whatever our a is. Well, in this case, a is 1/2, b is 3, because remember this is a times b to the power of x. So our graph should cross through the point 0, 1/2, and it does, because if we plug in 0, we get 1/2. So one of our points is going to be 0, 1/2. So a 0 up half, put a dot. Second point, plug in 1. So we get a half times 3 to the first power. 3 to the first power is just 3. 3 times, oh I'm sorry, I wrote a 3 here, that's supposed to be a 2. 3 times a half is just 3 halves, or 1 1/2. So our next point is 1 and 1 1/2. Put a dot. Now from left to right, you are going to draw a curve that follows these two dots, and it's going to be increasing, obviously, because these dots are going up. So your curve is going to look something like that. Doesn't have to be perfect, something like that. Make sure it never crosses the x-axis right here. If it looks like a times b to the power of x, just like we have here, a number times a number to the power of x, the x-axis is always going to be our asymptote. So don't let it cross the x-axis. So let's look at one that's going in the other direction. Again, I want you to plug in 0 and 1. We plug in 0. Now be careful with your order of operations. This negative is outside the parenthesis, so you have 3 halves to the power of 0, which is just 1. So your answer is going to be -1. So your first point is 0, -1. Your second point, if you plug in 1 for x, 3 halves to the first power is just 3 halves, so you have -3 halves. So your next point is 1, -3 halves, which is -1 1/2. Now, this is going to do the same thing, except you can see it's going in the opposite direction. And your -a will do that. It'll send it down instead of a curve going up. So this, you're going to do the same thing. From left to right, you're going to draw a curve that's following these dots that goes down. My curve isn't perfect. Just imagine it's perfect. Again, it's never going to cross the x-axis. Never cross the x-axis. Curving going down. Alright, let's look at something that's a little more complicated, and we have to state the domain and the range. Alright, you just learned that exponential functions are in the form a times b to the power of x. We're going to look at something that now looks like y equals a times b x minus h plus k. I know, these h's and k's are coming back to haunt you from all the other translations that we did. But this is pretty simple. You're going to be given a function that looks like this. Basically, we're going to make it look like that, and then just move it over and down. So it's not too hard. What we're going to do is we're just going to pretend that the h and the k is not there. So the number added at the end, and this number subtracted from the x. Just pretend that's not there. So pretend it looks like 3 times 2 to the x. That's it. Just pretend you have your a and your b to the x power. Just pretend that's all you have. Graph it exactly how you did before. So you have your 0 and your 1, which is pretty simple because anything to the power of 0 is just 1. So if you plug in 0, you just get 3 times 1, which is 3. And you already know that this is going to go through the point 0, comma a, and 3 is your a, so it's going to go through the point 0, 3. So you really don't even have to show your work right here, because you already know that that's going to happen. So you graph the point 0, 3. Put a dot. Then plug in 1. So you have 2 to the first power, which is 2 times 3, you get 6. So your other point is 1, 6. Graph that point. 1, 2, 3, 4, 5, 6. Put a dot. Right, now you're going to add in your little h and your k. Alright, so look at our formula. We have x minus h. H is going to be the translation right or left. So how it's moving right or left. K is how it's moving up or down. Start with right or left. Minus h. We have x minus 1. So that means our h is 1. So that means your dot is going to move over 1. Moving over 1. Look at k now. Plus k. We have minus 4. So our k equals -4. that means your points are going to move down 4. So I'm going to go down 1, 2, 3, 4. And 1, 2, 3, 4. So your new points are right here and right here. Now draw your curve based on those 2 new points. So your curve looks something like this. Now before, when you were doing these, I said make your curve and you never cross the x-axis. Your k is now your new asymptote. So if you have something simple that looks like this, a times b to the power of x, your asymptote is always the x-axis. But if you have extra stuff, an h and a k, your k is your new asymptote. So when you draw this curve, your curve should never cross the line -4, which is right here. So make sure when you draw your curve that your line doesn't go below here. We don't want that, because -4 is our asymptote. The last part of the question said state the domain and the range. Remember, the domain is the x values, the range is the y values. So if you have asymptotes, that's going to be part of your range. So here our graph is going to go up and up forever and ever and ever. I hope you agree with me. But it's never going to cross this line right here. This y is -4. So our range is anything greater than where y is -4. Because our graph isn't down here, we have to be above -4. So our range is where y is greater than -4. Our domain, well, this line's going to go on forever and ever and ever, and this one's going to go on forever and ever and ever. So really, it can be any x values. So our domain is all real numbers. And for a lot of these, your domain is going to be all real numbers. Alright, the last thing I want to give you is a formula. And we're going to do an example using this during class, because I don't want this video to get any longer. So I want you to write this down. When we use real-life models, and we're talking about exponential growth in real life, we deal a lot with money and growth rates for like interest over time. So this is an equation that you're going to use. And this is for a growth function. A is the initial amount, so like if we're talking about money, it's the initial amount of money. R is the percent increase, and it's written as a decimal, so if you have a 98% increase, you have to change it to a decimal, so 0.98. And that entire quantity, 1 plus R, once you add 1 to R, is called your growth factor. And that's actually how your graph increases, and I'm going to show you what I mean in class.